Imagine a sales manager reviewing one wild month. Maya broke every record, so he praised her. Leo finished last, so he gave him a severe warning. The next month, Maya fell back and Leo improved. The manager learned a perfect lesson: praise makes people soft, while punishment works. Except that lesson may be completely wrong. A monthly result is never pure ability. It also contains easy or difficult customers, timing, sickness, one lucky contract, one cancelled order, and ordinary measurement noise. When a result is extremely high, it probably contains not only strong performance, but an unusually helpful temporary push. Extremely low results often contain the opposite. The stable part may continue next month. The temporary part does not promise to return with the same strength. A lucky contract may not repeat. A terrible week may end. So the second result is related to the first, but not perfectly. That imperfect correlation is the doorway through which results move back toward their usual range. This pattern is called regression to the mean. After an unusually extreme measurement, a later measurement is expected to be closer to the average, especially when the two measurements are only partly related. It is a statistical pattern. It is not a personality flaw, a punishment from the universe, or proof that success cannot last. The trap begins when you choose cases because they are extreme. Pick the 10 hottest salespeople, the sickest patients, the worst schools, or the most dangerous road junctions. You have selected strong underlying cases, but you have also selected unusually large doses of temporary noise. That hidden selection makes the next measurement look like a story. Nothing physically pulls every score toward a center line. Maya could break another record. Leo could perform even worse. Regression to the mean is about what we expect across many repeated cases, not a guaranteed path for one person. The more extreme the selection and the noisier the measure, the stronger the average movement tends to be. Francis Galton documented the pattern in 1886 while comparing parents' heights with their adult children's heights. Children of very tall parents tended to be tall, but less extreme than their parents. Children of very short parents tended to be short, but less extreme. The relationship was real, yet it was not perfect. Now return to the sales manager. He praises people only after exceptional months, and punishes people only after terrible months. Even if his words do nothing, both groups are likely to move toward their usual performance next time. Praise is followed by decline. Punishment is followed by improvement. The timing manufactures a persuasive but false management theory. People often seek treatment when symptoms are at their worst. Pain peaks, blood pressure spikes. A bad week finally becomes unbearable. Then treatment begins, and the next measurement is usually less extreme. Some improvement may be real. But without a comparison, regression to the mean can receive credit that belongs to chance, recovery, or the treatment itself. Suppose a city installs cameras at junctions after an unusually bad year of crashes. The following year has fewer crashes. The cameras may help. But the locations were chosen precisely because the first year was extreme. Part of the fall could have happened anyway. Comparing them with similar junctions helps separate safety from statistical drift. The same mistake creates famous curses. An athlete wins an award after a career best season, then performs less brilliantly. A creator goes viral, then the next release is smaller. The trophy, or attention, did not have to cause the decline. Awards usually select peaks, and peaks contain unusually favorable conditions that are difficult to repeat. But do not turn regression to the mean into a universal excuse. A competitor can enter. A star employee can leave. A treatment can work. A policy can fail. A real cause can move the underlying level itself. Regression explains expected movement from noisy extremes. It does not erase evidence of structural change. A single before and after comparison is most dangerous when the before value triggered the intervention. The worse that starting point looks, the more dramatic an ordinary rebound can appear. If someone shows you only the peak, the intervention, and the next reading, you are seeing the exact three-frame story regression to the mean lobs. The first defense is more baseline data. Do not define normal from the single worst day or best month. Look at several measurements before the intervention. Repeated observations reveal the person's usual range, the metric's noise, and whether the apparent crisis is a genuine shift or one unusually dramatic point. The stronger defense is a comparison group. Find similar people, teams, patients, or locations that face the same background conditions without the intervention. Better still, Randomize when that is ethical and practical. If both groups improve, regression or shared conditions may explain the movement. If the treated group improves more, the causal case becomes stronger. Before you credit a punishment, treatment, coach, camera, or new policy, ask 4 questions. Was the case selected because the starting result was extreme? Is the measure noisy? Are repeated measurements only imperfectly correlated? And what happened to a comparable group without the fix? Those questions do not prove the intervention failed. They stop natural fluctuation from stealing the credit.